All right, so we got another limit problem here, and it's probably a L'Hopital's rule problem. But before we use L'Hopital's rule, we always have to check to make sure that it's okay to use L'Hopital's rule. And the way you know it's okay to use L'Hopital's rule is you verify that you have an indeterminate fraction. That is, you either get 0 over 0 or you get infinity over infinity. Okay, so what we're trying to find is the limit as x goes to infinity of e to the 2 over x minus 1 divided by 4 over x. Oh my gosh, where do they come up with these crazy functions? These are bonkers. But anyway, that's what we got. Okay, so let's think. How do I think about this? So the way I think about this is I just look at one piece at a time. So like I think as x goes to infinity, what's happening? I ask myself, what's happening to the denominator? So as x goes to infinity, well, x is getting really big and the 4 is stuck. So this fraction is going to be getting close to this bottom fraction, this denominator, that's going to be getting close to 0 because the top is the top is stuck at 4 and the bottom's getting really big. So anytime you have a small number divided by a really big number, that's close to 0. And then let's see, but now what about, let's see, okay, well, the same thing's going to be happening here, that 2 over x is going to be getting close to 0. Because, well, for the same reason, as x goes to infinity, 2 over x is, 2 is getting divided by a really big number, so that's going to get close to 0. Okay. Oh, and then, but if that's getting close to 0, I think, well, what's e to the 0? Well, e to the 0 is 1. So this guy is getting close to 1. Maybe I'll highlight that. This guy right here is getting close to 1. Oh, and then we're going to subtract 1. So when it's all said and done, I hope this made sense, the numerator is getting close to 0. So it's sort of just a chain reaction, and you kind of have to just look at it. Don't try to take shortcuts. Don't try to do too much at once. Like I said, just look at it one piece at a time. Like I looked at this, the 2 over x was getting close to 0. And then I think, well, what's e to the 0? Well, e to the 0 is 1. Okay, so this part here is getting close to 1. Oh, but then I have to subtract 1. So the entire numerator is getting close to 0. All right, so the point is now that means all that work, I did all that work, and what that work told me was that it's safe to use L'Hopital's rule, it's okay to use L'Hopital's rule on this problem. Okay, so I guess we'll give that a try. And now let me see, I'm trying to think if this is gonna work. I'm kind of worried actually. So let's think about this for a minute. Well, let's just give it a try. So, all right, so what does L'Hopital's rule say? So L'Hopital's rule says that I find the derivative of the top and then I also find the derivative of the bottom. Okay, well, I'm going to do the derivative of the bottom first because I think that's easier. The derivative of the bottom is going to be negative 4 over x squared. And I hope, I kind of did that fast, but hopefully at this point in your life, you found the derivative of 1 over x enough times that you know that it's negative 1 over x squared. I don't know if you have that memorized yet, but if you don't have it memorized yet, you probably, I try not to ask you to memorize a lot, but the only things I ask you to memorize are things that I think you'll use a lot, and so it'll just save you a lot of time. And so this gets used a lot. And the reason, let me remind you why that is. 1 over x is the same as x to the -1. And so then you use the power rule. So you get negative x to the -2. And that's just -1 over x squared. So that's how you get that. So you could, again, you don't have to memorize this. You could just do the power rule every time. But that just involves a lot of steps, and it's just time consuming. Whereas if you can just memorize this, it saves you a lot of time. Okay, so anyway, so the derivative of the bottom is -4 over x squared. And oh boy, now I have to find the derivative of the top. Okay, well, the derivative of the top is the derivative of e to the anything is just e to the anything. But then the chain rule says we have to multiply by the derivative of the anything. We have to multiply by the derivative of the inside. And so, okay, well, hey, I'm going to use this trick again, or this rule again. The derivative of 2 over x is going to be -2 over x squared. I'm just basically using this rule down here. And oh, and now actually that means some good things are going to happen here. Because let's see here, we're going to have the limit. Let's clean this up. Okay, wait. Let's be clear. So what happened right here was I did use L'Hopital's rule. And okay, and now I'm done with L'Hopital's rule. And now I'm just going to try to clean this up as much as possible and hope I can see something. So we have e to the 2 over x, and then multiplied by -2 over x squared. And then when I divide by a fraction, that's the same as multiplying by the reciprocal. So I'm just doing basic algebra here. That dividing by this fraction would be the same as multiplying by its reciprocal. And that's nice because then I see that I get some cancellations. That is like that. I got that x squared can knock out that x squared. Oh, and then these negatives will cancel too. So that'll be nice. So we have the limit as x goes to infinity of e to the 2 over x multiplied by, I guess, -2 divided by -4 is 1/2. 1/2. Okay, and now we're almost done. The last step is now try direct substitution. That is that what? I mean, I guess you're not really doing direct substitution technically because infinity is not a number. But the idea here is that as x gets really, really big, this fraction is going to get really close to 0. So we have, as x gets really big, 2 over x gets really close to 0. So that limit is e to the 0, and e to the 0 is just 1. So my final answer is 1/2. And that's kind of an interesting one because I don't know if I would have predicted that. Like we said, sometimes it's fun to, like I said, I think it's fun to go back and to try to see how you might have predicted the answer. But I don't see a good way. Personally, I don't see a good way to predict the answer. I wouldn't have guessed this. I mean, now that you look at it, you might say, oh, well, hey, 4 is twice 2. So that's probably has something to do with this. But yeah, that's true. That definitely has something to do with this. But I don't think I would have been able to predict that at the beginning. Because, what I would say, what happens to the E? Where did the E go? And, that's a little bit of a mystery. So that was an interesting one, in that we got an answer that we might not have predicted. All right, so that was a fun one. Oh, wait. So let's review, let's recap there. So the steps in L'Hopital's rule, again, if you have a fraction, first step is verify that you have an indeterminate form. So that we did that first. We verified that we got 0 divided by 0. And then once you know that you have an indeterminate form, then you can use L'Hopital's rule. So you find the derivative of the top and you find the derivative of the bottom. And I should say, I was worried when I first looked at this. I thought, uh-oh, this is bad, because the denominator got more complicated and the numerator got more complicated. So normally when you use L'Hopital's rule, you hope for things to get less complicated. But I was kind of worried about this problem because the numerator and the denominator got more complicated. But it turns out we got lucky because there was a nice cancellation. So that's true. So L'Hopital's rule sometimes is kind of tricky in that, and the moral is don't give up, or don't give up right away. That sometimes things look like they're getting worse. But if you look at them the right way, they actually are better. So that's another good point. Another thing to keep in mind is simplification is your friend. That there's a reason why we spend so much time making you simplify things in pre-calculus. And the reason is that when you get to calculus, being able to simplify things becomes pretty important. Okay.